This is a quick how to set up Microsoft's Azure Machine Learning Studio to work with the national parks data. So we're going to start from the beginning, which you may not have to, but at the very beginning, we of course are going to need to create a workspace. You can name the workspace whatever you want. I'm going to call this National Parks. Choose your valid subscription and create. We'll go through the workspace validation and then the provisioning on Azure. And after 10 to 20 seconds, it should be provisioned and then you can click through. Now that it's been provisioned, we can open our workspace. If this is a new workspace, you probably need to set up the compute. So this is the compute instance you're going to use. And for this, we want a compute cluster. This just lets us run and execute our notebook. So we'll create a new compute cluster, right? Dedicated CPU, those are all good, as is a general purpose machine for the quarter and hour. So click next. We'll give it a name. I'm just going to call this National Parks Compute and create. This can create in the background and we can start making our designer workflow. So go over to designer. We want a classic pre-built, and we want to create a new pipeline using these components. We're in our workspace. We have no user uploaded data, so that's the first thing that we should do. Click the plus, give your asset a name, call it National Parks, and this is a tabular file. It's a CSV file that we downloaded from iCollege. We're going to upload it from the local file that we downloaded. We can put it in Azure Blob Storage. And then we want to upload the file. So National Park user data. This is a little bit bigger than the credit data. But now it'll validate it. It's a delimited file. You'll see a preview here, right? So everything starts with a large number of attributes. And then at the very end, we have our label column, National Parks. That's whether someone's already liked the National Park fan page or not. Go through our schema here, right? These attributes related to personality, those are decimals, but everything else is an integer. So it's reading it through. We can click next and then create the data. So we have our national parks data. If we want to filter out the columns that we want to use to look at something, you can look for select columns. So if you don't want to use all of the columns in the data set, you can select columns. And select columns is giving us this red triangle with the exclamation mark because it wants us to tell it what columns to use. And so we can select columns either by rules or by name. We can include column names. So, right. Let's say we wanted to include gender, age, their political affiliation, their personality attributes. Oh. Right? We want to include those things. Didn't want to include any of the individual pages that people liked. That's perfect. We always need to remember to also include the national parks because that's what we're trying to predict. If we wanted to do the opposite and just do all of the pages that people liked and nothing about their demographics or personality, we could change this from include to exclude. And we could do column names again and put in the column names that we wanted to exclude. So there's a variety of ways to add or remove things. You should generally think about what's the least number of column names you need to click if you want to use them. All right. So we'll close that. If you want to use all the columns in the data set, it's very easy. You just don't use select columns. Now, if you're not using select columns or if you are using select columns, before we actually use the data to train and test the model, we need to split the data. So when we split the data, we want to split it into the training and the testing. This file has about 10,000 individuals, which isn't really that many considering how many columns there are in the data set. So we want quite a bit of data to train with. So we'll want to have 80% of the data to train with. We want them to be randomly split, but because there's so few people, we want to make sure that when we do split the data, we're making sure that the ratio of people that liked the national parks page to the ratio of people that didn't stays roughly the same in the testing and the training data set. That means that we want to stratify the split based on that column. So we just say that we want to stratify it. And we want to stratify it based on the national parks column. You can use any model that you want, right? But what's easiest is to stick with what we've already been playing with, which is our decision forest. And this is a two-class problem again. So we want the two-class classification version of the algorithm. Now we don't need to do anything with the parameters here because we're actually going to ask / use the tune model hyperparameters instead of the train model. Tune model hyperparameters will actually do the parameter exploration to find the best working version of this model. So it takes in the untrained model and the training data. And then we need to configure the tune model hyperparameters. This is going to run in the background. So you can just set this all up, press play, and then it'll go and run. So the maximum number of runs is the number of different parameter combinations it's going to try. I suggest doing something like 250 or 500, depending upon how long you're willing to wait. We'll do 250. But this is something that you can do. You just set this up, press play, and then come back in a couple of hours. We don't need to change this random seed, but we do need to tell it what we want it to optimize. So this is the metric that you want it to optimize, and that will let it determine what the best model is. So you can use accuracy, precision, recall. This means that you're going to have to make a decision about what the metric is that you think matters the most. So by default, so no one reads anything into this, I'm going to stick with the default of accuracy. And I'm going to set up the label column. This is telling it what it is trying to predict. So again, we're predicting national parks. And what comes out of tune model hyperparameters is sweep results and our trained best model. Sweep results is going to be the results of all of the different parameter combinations it tried and their performance and classification. By default, this is an Azure specific data object. You may want to download this so you can look at it in Excel. And so when you want to be able to download data out of it, you can search for the CSV. There's a convert to CSV function. This will let you download data out of the Azure workspace as a CSV file after you run it. So we'll do that so we can get our sweep results out. Now, in terms of the model, we're going to want to make predictions with it to see how well it performs on new data, i.e. our test data. So that's scoring a model. So we'll use our trained best model and our test data. And after we make predictions, we need to evaluate it. So we'll search for evaluate, and then we want to use evaluate model. This takes the scored data set, and it's going to give us essentially our classification performance. Now, if we want to understand what's driving the model predictions, then we can use the permutation feature importance. This is going to randomly scramble the data in a column to assess how much it impacts the model's ability to make a prediction. The more that the scrambled data makes the prediction worse, the more important a feature is in making the prediction. So this requires a trained model and test data, and it puts out the feature importance, the ranked list of the columns and how important they are in making the prediction. This is something that we're also going to want to convert to CSV so that we can save it and look at it in Excel. Right. There we go. And now we have a fully wired workspace. We can configure and submit this. We'll give it an experiment name. Going to call this National Parks Demographics because we didn't include any of the page likes. I'm going to choose that compute cluster that we set up in the very beginning. And then I can submit it. We can see that the pipeline job has been submitted. It's going to let us view the details. And now this is going to take an hour or so to actually go and run. You can always leave this page open, but at any time, right, you can also look at it in this left-hand pane. Under assets, there's this jobs list. These are all of your running jobs. So at any time you can come back, click on a job. You'll see this pipeline name. Right now it's running, right? It'll still be here even when it's done. And you can click on it and look at where it's at in terms of its progress or the results. To give you an example of this, I've already run a model in the past, right? For class, this is everything related to our credit data. I still have all of my jobs here. This is a job that was created with those tune model hyperparameters, right? And you can access everything. So this is different data, but to show you everything that you can access. So you can look at the sweep results from tune model hyperparameters. So with the credit data, you can see the different runs. This was a smaller job. Oh, accidentally went back. Right. Make this bigger. There we go. So you can see the different parameters that were used and what the performance was. So our best performing model here had 8 decision trees with a depth of 64. If I wanted to download this data, you can right click on convert to CSV. You can preview the data, the results data set here. Right? Still the same data. But now if you actually want to access that data, go to the results data set. It'll take you to a new page where you actually get that CSV file. You can download it, allow downloads. And that'll get you your data file out. Score model, evaluate model. Oh, wrong page. There we go. Score model and evaluate model are still the same thing. You can preview this data. Your evaluation results will come up. And feature importance. Will show you the columns and they will be ranked by how important they are. Now, importantly, like I said in class, this is not an absolute scale. Everything is relative here. So the way that you should interpret this is if number of times 90 days late is 0.003 and number of times 60 to 89 days late is 0.0009. The number of times 90 days late is 3 times as important, roughly. So this is everything that you should expect to see and have access to once a model is done running.